All right, so this is bearing and navigation day 2. It's called a warm-up, but really it's just extra practice. So we'll go ahead and do this together. So directions, once again, round angles to the nearest tenth, lengths to the nearest hundredth. So the first one says, after an unfortunate camping incident, you've been lost in the woods for days. You finally walk into the clearing and realize you're on top of a cliff. Your only option is to climb down the cliff. From the top of the cliff, you spot a barn in the distance. If the angle of depression to the barn is 32 degrees and the barn is 2 miles away from the base of the cliff, what's the height of the cliff? So really what this is good practice for is SAT and making sure you know what an angle of depression is. Okay, so an angle of depression, and I'll talk about the other one too, which is an angle of elevation. First off, you always need a horizontal line. So we'll do angle of elevation and angle of depression. So there's a horizontal line, right? 2 of them, they're auxiliary lines. An angle coming up from a horizontal line, so like this angle right here, that's an angle of elevation. An angle of depression would be an angle coming down from a horizontal line, so this right here is an angle of depression. So key thing is you need the horizontal line to come down from first. Okay, so let's go ahead and draw this once again. So once again, if I skim through this, you're on top of a cliff. So cliffs are vertical, so I'm going to draw a vertical line. Your only option is to climb down the cliff. From the top of the cliff, you spot a barn in the distance. So like this is where my barn can be. If the angle of depression to the barn. So in order to draw an angle of depression to the barn, I'm going to need a horizontal line here. And then I can draw an angle going down to the barn like so. So if the angle of depression to the barn is 32 degrees, and the barn is 2 miles from the base of the cliff, what's the height of the cliff? So if the barn is 2 miles from the base of the cliff, I know this distance right here is 2 miles. Notice I just made a right triangle, and the question is, what is the height of the cliff? So that's X right here. Since this is a right triangle, we can use SOHCAHTOA. So SOHCAHTOA. We just have to figure out which trig function we're using. So if you look, you don't have any angles inside the triangle right now, but you do have a set of parallel lines. This horizontal line and this horizontal line are parallel. This is a transversal, and we know alternate interior angles are congruent, so I know this angle is 32 degrees. You could have also figured out what this angle is right here, considering the fact that this is 90 degrees, but it's good practice with the alternate interior angles. All right, now looking at this triangle, let's see what we have here. We're using this angle. This side is opposite because it doesn't touch the angle at all. This side here is adjacent because it touches the angle, and it's not the hypotenuse. So O and A, we use tangent, so we're going to use a tangent function to solve this. So I'm going to write down tangent. My angle always comes next, which is 32, equals, and then I have to do O over A, opposite, which is X, over adjacent, which is 2. This is a proportion. As soon as I put this over 1 now, it's a proportion. The easiest way to solve a proportion is by cross multiplying. So if I multiply these two, I get X equals, multiply these two, 2 times the tangent of 32. Remember to put that 2 in front so it doesn't look like tangent of 322. Make sure my calculator is in degree mode, which it is. And then 2, tangent, 32, enter. And I get X equals, which is the height of the cliff, 1 point, since this is a distance, I'm using 2 decimal places per the directions, 25, and then I want a unit on this, and it is miles. So even though it's strange to measure a cliff in miles high, that's what I'm doing right now, 1.25 miles tall. All right, let's look at the next one here. The next one says to fly from Egdon to Heath, a plane follows a course of north 68 degrees west. Find the course a plane flying from Egdon to Hardy and Heath to Hardy should follow. Okay, course is just bearing, direction, same thing. So that's just something good to know right there. Course is bearing, direction, same difference. Okay, so it starts off by saying to fly from Egdon to Heath. So since you're flying from Egdon, that's our starting point. That's where we're going to draw our compass. So I'm going to draw a compass at Egdon. It's already got the point of where Egdon is. So I am just going to draw what looks like an X and Y axis, but really is my north, south, east, west compass. Okay, so I'm also going to label it, never eat soggy Wheaties. Okay, so to fly from Egdon to Heath follows a course of north 68 degrees west. So make sure you're looking from Egdon to Heath. So I'll, trace that. Oopsies. Turn my paper to try to chase that. So here's the course or the bearing that I'm looking at. And it says that is north, 68 degrees west. So from the north towards the west is 68 degrees. And then I can do 90 minus 68 to figure out what that other angle is. 90 minus 68 is 22. So I know that this angle is 22 degrees right here. Okay, so now that's the information I was given, and it says find the courses of plane flying from Egdon to Hardy and Heath to Hardy. So we have to do one at a time. Let's do Egdon to Hardy. Okay, so let's start with Egdon to Hardy. So I need to put a compass at Egdon, but there already is one there. But I'm going to do Egdon to Hardy. So we want to know what's this course right here. So we want to know what is that. Okay. So if you look in this diagram, what's already included is the distances. So it wasn't written in the problem, but they're already there. So I already have all three sides. Okay. So I already have side, side, side. I realize that I need this angle right here, but the good news is that if I find this angle right here, I can call this whole angle right here theta. If I can find that, let's say I get theta is 100, then I just do 100 minus 22, then I'll know what this guy is right here, okay? So that's what I'm going to do is I'm going to find that angle, and I am using side, 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 so because I have three sides, side, 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 so I'm using law of cosines. Okay, remember with law of cosines, you have to find the biggest angle first. But if you look, well, actually if you're solving the whole triangle. But if you're just finding any angle, you can use whatever you want. Luckily, we're finding the biggest angle first anyways, so it shouldn't mess you up in any matter. All right, so since I'm finding that angle theta, I'm going to start with the side opposite of it. So I'm doing 146 squared equals 93 squared plus 118 squared minus 2 times those two sides, so 93 times 118 times the cosine of, and then I called the angle theta. You could call it E if you want for Egdon, right? But then there's Heath and Hardy, both start with an H, so. All right, so now I need to solve this. Remember, this is all stuck together right here. So I'm going to make it one big bucket and see what that is. I'll make this one bucket and this one bucket. All right, so be very careful with these because these are bigger numbers. 146 squared is 21,316. 21,316. Make sure you write down the numbers accurately, type them accurately. 93 squared plus 118 squared. 22,573. Minus, and then I'm going to multiply those three numbers. 2 times 93 times, oops, that's not 2, see? If you look, you'll find your mistakes. Times 93 times 118. And I get 21,984. Sorry, 948. Cosine of theta. All right, now remember you're solving for cosine, you're solving for theta, which is attached to cosine, which is attached to that negative 21,984. So first thing I'm going to do is I'm going to get rid of this 22,573. I'm going to subtract those and see what I get. So I have 21,316 minus 22,573, and I get negative 1257. So negative 1257 equals negative 21948 times the cosine of theta. So now I need to get rid of that negative 21948. Remember, this is multiplication, so I'm going to divide. Negative 21948 divided by negative 21948. Realize this is a negative divided by a negative, so yes, you can get rid of them. I'm not going to. I'm just going to leave them the way they are. All right, so now I have cosine of theta is equal to this. And remember, I have to get theta by itself. So I'm going to cosine inverse both sides. So I'll cosine inverse this side, cosine inverse this side, and then these will cancel. So I have theta is equal to cosine inverse of negative 1257 over negative 21948. Remember, you want this on your paper because this is what you're typing in your calculator. So cosine inverse negative 1257 divided by negative 21948. Close parentheses, hit enter. And now I get theta is equal to 86 point. Remember, degrees are nearest tenth, so I can just put 86.7 degrees. Okay, so now remember, this is not your answer. This is what theta is. And if you notice, I'm going to have to use it to find any other angle that they ask me for. So I am going to store this in case I need it. If I don't, big deal, then I'll save over it. But I'm afraid of losing it. So store. And then now I'm going to find the first thing they asked me for. Find the courses of plane flying from Egdon to Hardy. So now I'm going to find that. So I want this course right here in red, which I just highlighted again, which might be hard to see since it was red on red. So I highlighted it in yellow. So I want to find that course right there. Okay, so I know instead of calling this theta, I can say that this angle is 86.7. Now I can find this little angle right here. So 86.7 minus 22. X minus 22. X minus 22 is 64.7 degrees. And now I can state what that course is. So you can do it either method. I think it's easier to do the north clockwise method right here. Oops, that doesn't look so pretty. But yeah, I think it's easier to do that. Or you could find this right here, okay? Whatever you would like to do. So I do need this angle either way. So let's find this angle right here. And I'm going to do 90 minus second answer. And I get that angle is 25.3 degrees. So from, what was that, Egdon to Hardy? Egdon to Hardy is south 25.3 degrees towards the west. Or you can do this angle right here, which is 180 plus 25.3 degrees. So I'll just do second answer. And I get 205.3 degrees. So there's Egdon to Hardy. All right, now that's not the only thing that was asked for in this problem. It was also asked to find from Heath to Hardy. Okay, so now I have to do Heath to Hardy. So there is no compass at Heath. So I'm now going to have to draw a compass at Heath. I'll do red, I guess. Actually, I'll do pink. I'll match my other compass. So I'm going to start at Heath, and I can just move it if it's not perfect. So there we go. All right, so there's my compass at Heath. I'm going to do my north, south, east, west, northeast, southwest. I'm going to get rid of this S right here that's lingering. All right, so find the bearing from Heath to Hardy. So I'm going to highlight that in a different color. I'll use green. Heath to Hardy is this bearing right here. That's what I want next. Okay, good enough tracing is what I'm going to say. All right, so let's see what I do know, because right now it looks like I have nothing in here. But remember, whenever you draw two compasses, you have parallel lines. Parallel lines are going to be cut by a transversal, and you'll have alternate interior angles that are congruent. So this line right here is parallel to this line. If you look at this blue line right here, that's creating a transversal. So I do have alternate interior angles, and I do know that this angle right here is 22 degrees, okay? Now, how is that helpful, you might be saying? Well, I know that this whole thing right here is 90 degrees, so if I do 90 minus 22, 90 minus 22, that'll give me this whole angle right here. Now, it's not, I'm going to need that whole angle. It's not my answer, but it'll at least give me a start. So 90 minus 22 is 68. So I know this big angle right here is 68, and I can use that in the future. I can write it down right now and say that's 68 or use it later. All right, so what I do know that I need to find is I need to know what this angle is right here. Because if I know what this angle is, let's say it's 50, then this would be 18 because those two together make 68, right? So let's find that angle now. So I'm going to put let's use alpha. Let's not use theta again. So I'll put an alpha right there. And since we already used law of cosines, we're going to switch to the law of sines. Also, I already put the 86.7 there. Okay, so we're going to start the ratio that we do know. Sine of 86.7, which I'm just going to put theta, and it's stored as x in my calculator, right there, over 146 is equal to, now I'm trying to find this alpha right here, so sine of alpha over its opposite side, which is 93. And now let's solve for alpha. So I have 146 times the sine of alpha is equal to 93 times the sine of theta. I'm going to divide both sides by 146. These will cancel, and now I have to get rid of sine, so I'm going to sine inverse both sides. So I have alpha equals sine inverse of 93 times the sine of theta, which remember is stored as x. I'm glad I stored it because it's long gone on my calculator. All right, so sine inverse 93 sine of x, close the parentheses, divided by 146, and I get alpha is equal to 39.5 degrees. So now I know that that angle alpha, I can erase that, is 39.5. That means I can figure out what this angle is too right here. So let's figure out what that is. I can do 90 minus 39.5 minus the 22, and I get 28.5. Oopsies. Let me zoom in to try to only get that. So this is 28.5. So now I can say the bearing or the direction or course from Heath to Hardy. So Heath to Hardy. All right, so method one would be south towards the east. So south 28.5 degrees east. Or if you want to use your other method, you can start from the north and go until you hit that. So that would be from the north until I hit that right there. So that's 180 minus 28.5. Minus 28.5, and that's 151.5. So, or 151.5 degrees. Once again, it doesn't say you need to have both, so if you get the first method or the second method, just stick with it.